Hi everyone, and thank you for choosing to spend your afternoon with us. I'm Nadia, and I am a biostatistician in the Division of Health Analytics at City of Hope, which is a comprehensive cancer center based in Los Angeles County. And I've been with City of Hope for about 10 years now, and my background is in biostatistics and epidemiology. However, as we've modernized our data structure, my role has evolved to also include more data management.
Good afternoon, everyone. I'm Emma. Thank you for being here with us. I started working at City of Hope just over a year ago in 2018, and my role is to improve data quality and documentation for our study, and it's also to help guide our users through our data to help them understand it, and Tableau is a big part of how I do that.
All right, so I'm going to talk a little bit about what the California Teacher Study is and what we do, take you on our data journey, and Em and I both will go into some internal and external use cases using Tableau. I'm going to sum everything up and highlight some of our key accomplishments and future directions. So, in the late 80s, the California Department of Health Services first noticed that there were higher rates of breast cancer among teachers in California. And this got cancer epidemiologists and researchers into questioning why teachers specifically. So I want to ask you guys that question and see if anyone has any ideas as to why teachers might have higher rates of breast cancer. Just go ahead and shout it out. It's a good one, okay. Okay, good ideas. What was that?
No time off.
All right. Good one. Okay. All right. So. Okay, so all good ideas. I see that you guys are all thinking like epidemiologists. This question is what started the California Teacher Study, and what we found on our study was that teachers had less children. For those that did have children, they were more likely to have kids at a later age, and also they were more likely to take hormone replacement therapy. So these were the common three that we found. Okay. So as I mentioned, the California Teacher Study began to investigate this excess risk of breast cancer among teachers. And so we started in 1995-96 when 133,479, to be exact, female teachers completed and mailed in a self-administered questionnaire. And since then, we've administered 5 follow-up questionnaires that have collected data on many different areas of potential scientific research. So before I continue, I kind of want to define some epidemiology terms so that we're all on the same page. So the California Teacher Study, or CTS for short, is an observational study. And what that means is that we collect self-reported data from volunteers and connect this data to local, state, national health outcomes resource data, such as the California Cancer Registry for our cancer data, the Office of Statewide Health Planning and Development for hospitalization data. And under the realm of, or the umbrella of an observational study, we are a cancer epidemiology cohort. And what this means is that we're following our participants over time to track whether they develop cancer. And then we investigate whether the self-report data we've collected on these women have any correlation to the cancer that they developed. Our cohort consists of 4 collaborating institutions, and the data is largely managed by City of Hope and UC San Diego today. All right. So although our cohort started as a result of one-time funding using cigarette sales tax revenues to study this excess risk of breast cancer, we continue to receive funding to this day to not only collect data and study cancer, but other health outcomes as well. And so what this looks like is we collect and maintain data because studies like ours are required to do so, and researchers and collaborators will come to us with their scientific research questions, see if we have the data that they need, and if the answer is yes, they'll utilize us as a resource for testing their hypotheses and generating groundbreaking analytic results and findings. And all these new insights and discoveries hopefully get published in scientific papers. Okay, so on this screen, I have 2 screenshots from our study website. The very top is going to be our publications page, so if anyone's interested in sifting through all the papers that we've had published, please take down that URL. You'll be able to find all the papers that have been published using CTS data since 2002, and right below that is a screenshot from our what we are currently studying page, so if you're interested to see what topics we're currently using our data for, go ahead and go to that URL. So, as I mentioned, studies like ours are required to make our data available for research. And some of the obstacles that we face in doing so have been, how are we going to do this at scale? And how do we help new users understand the depth and complexity of the millions of data points that we've collected over the last 24 years? So how we've overcome these challenges has been by integrating Tableau in our day-to-day processes. So next, I'm going to give you guys a little bit of background as to our past and present data structure. So begins our data journey. Okay, so this schematic right here is our inherited data structure. I want you guys to just look at this briefly and not be bogged down by the detail and try not to run for the hills. So as I mentioned, the CTS is a collaboration between 4 institutions. So each of the different colors is going to correspond to a different institute, and each of the little boxes correspond to the data domain that they manage. So all this represents 151 static data sets across 4 sites, across 34 users. This is what we inherited. So they're all separate, and what this meant was whenever there was a new linkage file, so let's say USC, who is in charge or who was in charge of managing our cancer data, if they got a new linkage file, there's a single individual at that site that has to wrangle up all the data that they've accumulated in the last however many years on the study, go through their paper-based documentation and figure out all those multiple manual merge steps that they had to go through, put together this individually curated data set that gets dispersed to all the other sites. So not only was this a manual process, it was time-consuming, prone to human error, and required lots and lots of paper-based documentation that oftentimes got lost. So we no longer have to worry about local data storage and inconsistent data rules any longer. We have a single source of truth, and that is the CTS Data Warehouse. So all those little data sets I was telling you about, they're represented at the top in the data silos. We put them into a data repository where the data gets collated, goes through the ETL process, data gets piped into these staging tables where we've applied validation rules and coding algorithms, and voila, you get the CTS Data Warehouse. So the beauty of this is not just the fact that we don't have to have a single person at a single site having to create all these rules, but we're not dispersing data sets outward. We're inviting everyone into the same environment, which is promoting collaboration, and our biostatisticians, our cancer epidemiologists aren't having to spend their time doing data management. They're actually being able to have more time to work on their science. So, in addition to not having to worry about old, expired data sets containing PHIs circulating on over 100 computers, potentially all over the world, we've also implemented user-based data access. So in our environment, we have 3 specific roles that you can be assigned to. That's data manager, analyst, and researcher. And so people only need to see the data that they need to see to do the work that they need to do. All right. So all this sounds great, but you can imagine that moving from static data sets to a data warehouse has been difficult to implement. And on top of that, we're asking our users that are unfamiliar with business intelligence to start using Tableau for data visualization. So in order to onboard our users, we decided to start by recreating something familiar so that people can see the immediate benefits of Tableau. So every year in our study, we used to come out with this report that was called Useful Numbers. It was a 20-page static PDF that summarized important demographic information, distribution of cancers, hospitalizations, mortality, and biospecimens we've collected on an annual basis. And this screenshot that I have on that left-hand side, it's one of the common questions that people are interested in for their analytic population. They want to know what the age distribution is at the start of the study as well as the active cohort currently. Looking at a static report like this, if I wanted to use this data in November of the same year, obviously it's not going to, printout is not going to tell me what my age distribution is of the active cohort because people age, obviously, and people get lost to follow-up. So taking the same exact information, we piped it into Tableau, and what you have here is on one view, you can select a specific date and your population's dynamically calculated. All the rules are embedded in there. So here's another example of how we've made our reports more intuitive. So you're looking at our mortality data, and on the left-hand side is a distribution showing every single column is going to correspond to year on the study, and every row is going to be a specific cause of death. And me looking at this, it looks like numbers filled in on graphing paper. So nothing really is popping out. I don't see any trends off the bat. Taking the same exact information, putting it into a Tableau dashboard, and I'm able to see, if you're looking at the x-axis, which is year on the study, y-axis participant population, and each color corresponds to a specific cause of death, I can see that the green, dementia, is increasing over time, which makes sense because of our aging population. Additionally, if you look at the very top, you'll see the largest contributing cause of death in our population. So we learned early on that simply taking our pre-Tableau products and putting it into Tableau wasn't going to be enough. It was us asking, now that we have a bit of sense of what data visualization can do, how can we help answer our new users' questions rather than just recreate something in the past? So in addition to being able to visualize our study data, we also have been able to utilize our metadata. If a researcher comes to us and is interested to know what kind of data that they need, they no longer have to go to Emma or myself and ask that question and wait for us to get back to them via email. Instead, we have these interactive visuals where you're able to go in and filter on the topic or questionnaire of interest. So thus far, we've been able to help our users embrace our new data structure, the data warehouse, in the last 3 years. And they've been using Tableau more to see the different avenues of research that they can do because of Tableau. And Emma is going to go over some specific use cases with our researchers.
Thank you, Nadia. So as Nadia said, I'll be walking you through a few use cases for how we use Tableau to engage our researchers. So what does Tableau do for our researchers? Well, before we had adopted visualization through Tableau, our data was of course presented in flat, static files, and a big issue with it was that it could only be understood by experts. So these were expert epidemiologists and expert biostatisticians. What integrating all of our data and adopting visualization through Tableau has done for us is allowed us to reach a broader group of users who are not necessarily epidemiological experts. So now that our data is dynamic and it's interactive, new types of users can get more out of it. For example, we now have physicians who are using CTS data to publish scientific findings. So what do our researchers want? The ultimate end goal for all of our researchers will be a customized subset of our data on which they can run an analysis, which will in turn lead to a scientific publication. Between a researcher's first contact with us and this end goal, We use Tableau along the way to enhance their understanding of the data that they're analyzing. And as you can see from the hearts, this occurs at both the exploration and analysis phases, and I have a use case for each of those phases. So the first use case is at the exploration phase, and it's how we use Tableau to make our data digestible. When a researcher first comes to us, they tend to always have the same first question, which is the one that you see on the screen. Do you have the data that I'm interested in? Keep in mind that we have an enormous amount of inherited and linked data, as Nadia talked about in our data journey, and that following over 130,000 women for over 20 years has given us millions of data points to work with. And it's a lot to ask of our users to sift through all of that data. So we don't. Here are 3 examples of the types of questions that a user might ask during the exploration phase. How many biospecimens do you have from women over 50? How much of your population smokes? Or how many of your participants have been diagnosed with a particular type of melanoma? To address these pre-analysis questions, we've developed a handful of Tableau workbooks for our users, which act as little bite-sized pieces of those millions of data points and can give kind of an overview of what our population is like for anyone who's new to our data. And so I'll take you through these 3 workbooks that can answer these questions. The first workbook is Useful Numbers, which, as Nadia mentioned, replaced a yearly PDF. And it contains handy information on key life events for our participants. So this is things like dates of birth, dates of death, did they get cancer, did we collect a biospecimen from them? And Useful Numbers can answer a question like this one: how many biospecimens do you have from women over 50, in a simple visualization like this. So you're seeing 5-year age groups on the x-axis and number of participants who have biospecimens on the y, and it's as simple as that. Useful Numbers was the first CTS Tableau workbook, and it was a little bit before my time. But by the time I had joined the team, we realized that we needed to expand our use of Tableau beyond just these key life events to address more of the questions that we were getting from our users. And once we were listening to the questions that our users were asking us, what we realized is that a lot of their questions were the same. So they were asking us the same questions over and over again, and we were creating workbooks to answer those same questions from scratch over and over again. What we realized is that all of our researchers want to see certain core characteristics of our population. These are things like race, socioeconomic status, family history of cancer, alcohol and tobacco habits. And so we decided to create an off-the-shelf workbook, which we call Standard Data, that contains all of these core characteristics, so we don't need to keep making the same thing over and over again. There is a PDF of it available on our website if you'd like to check it out. Of course, it's not fun and interactive like Tableau is. It's on the For Researchers page, and this is also the page if you do happen to be a scientific researcher who wants to collaborate with us. You'll find information there about how to access our data. So Standard Data can answer a question like this one: how much of your population smokes, in a dashboard called Alcohol and Tobacco. So all a user has to do is navigate to that dashboard, and they can easily see the percentage of our population that reported that they never smoked, formerly smoked, or currently smoked at the time of our first questionnaire. And you can also see the number of participants, the frequencies, in the tooltips. Standard Data is a workbook that's available to all of our researchers, and since we created it, it's helped in the exploration phase of many of our projects. The third workbook is our Cancer Workbook. So this is a workbook that's based on data that we get from the California Cancer Registry, and it contains frequencies of cancer types, cancer subtypes, and tumor details in our population. What you're looking at here is one of my favorite graphs personally. We call it the rainbow graph. And what you're seeing is cancer type, each color corresponding to a different cancer type, over time on the x-axis by year of diagnosis in our population. And what's cool about this visualization is that if you click on one of the boxes, in this case it'll be melanoma, you can get a better look at the trend over time. So in this case, you can see a trend of increasing melanoma diagnoses as time goes on, as our population is aging. The cancer workbook can answer a question like this one: how many of your participants have been diagnosed with a particular type of melanoma, in a dashboard called Tumor Details, right next to the rainbow graph. So all a user has to do to get the answer to this question is go over to the cancer filter on the left-hand side. They select their cancer of interest. In this case, again, melanoma is selected. And instantly all the other tumor details, so this is site, stage, behavior, grade, and histology, will be instantly updated to match their cancer of interest. So if we have a researcher who wants to do an analysis, but they need to know how many participants have melanoma with a histology of 8743, all they have to do is select melanoma in the cancer filter, and immediately they can see that 572 participants meet this criteria. So Nadia and myself love these exploratory workbooks because they allow a much greater level of independence for our researchers in that initial exploration phase. Because they can poke around themselves in the data, it saves us enormous amounts of time that otherwise would be spent answering their questions, and it's a big part of how we do what we do at scale. Additionally, feasibility reviews, so that's where we're trying to see, do we have enough of, or a large enough sample size of a particular condition or cancer to run an analysis? That can happen virtually instantaneously, as we saw with that melanoma histology example. One consideration, though, that I'll mention is that anticipating what our users will want to see is not a science, but when we do see the same types of questions coming up over and over again, researchers keep asking the same thing, we do modify these workbooks iteratively to address those questions. So our second researcher use case is now at the analysis phase, and I'm going to explain how we use Tableau story points to visualize study populations. So no project that we are a part of is going to use all 133,479 women's data. Instead, every project will begin with a process that we call cohort selection. So this is where we're determining who needs to be included and who needs to be excluded in a particular analysis. An example of an exclusion would be as simple as exclude women over age 65. All scientific papers will document these decisions in a paragraph, a table, or both. In this paragraph from a CTS publication, everything highlighted in yellow are their exclusions, their cohort selection paragraph. For example, just to pull one out, there were 7,027 women who had breast cancer before this particular study started, so they decided to exclude those women. And I'll also draw your attention to this number at the bottom, 111,000. At the very bottom of the paragraph, what they're doing is making it clear that this is the final analytic population on which their analysis was run. Previously, creating a paragraph like this would require a significant amount of program hopping. So you would take your output from a statistical program, usually SAS, you would then put it in Excel, and then you might email it to someone via PDF, which is now static. This process wasn't standardized, sometimes even within small research groups, and it would be done ad hoc for every single analysis. Our solution to this has been to create an equivalent of this paragraph in Tableau using Tableau story points so that it's standardized, dynamic, and easy to understand. It's customizable but also standardized, so it basically serves as a template for cohort selection. And I'll show you what I mean. This is what the eligibility story that we give to our users looks like. The first story point is always used to show the full population of women of our study. So here you see that 133 number. This particular analysis was interested in second cancers in women over age 50 at the time of the first questionnaire. So in this next story point, because they were interested in women over age 50, we show that full age distribution of our population. Then we show the age distribution again, only for women over 50. And you can easily trace how our denominator went from that full population now to this 77,000 number. Because our analysis is interested in second cancers, in the next story point, we show the full distribution of the number of cancers per participant. Then we pull out this 60,000. This is the number of women who had no cancer diagnoses. We pull out 14,000 who only had one. And we can now see that our denominator is 2,679 women who had 2 or more cancers during follow-up. And we use this last story point to make it clear that this is the final number, the final analytic population on which the analysis will be run, just like we did at the bottom of the paragraph in the scientific paper. So a quick recap of why these eligibility stories are cool. They provide a great start for scientific papers, but even more importantly, they give a clear reference for why the denominator is what it is and prevents any confusion about that. We just went from this population of over 130,000 women. We brought it down to just the 2,600 that were relevant to our analysis, and we've done that in a standardized way. So if the researchers come back to us and they say, actually, we'd like to focus on women over 60, or we'd like to exclude based on a certain menopausal status, we can add story points, we can modify them, or we can take them away to meet whatever needs they might have. Next, I will hand it back over to Nadia, who's going to talk about some of our internal use cases for Tableau.
Thank you, Emma. All right, let's see where are we. So internally, we use Tableau for data management to generate numbers for grant proposals, as well as to document and forecast our project numbers. Our job as data managers have been to continuously manage data updates and also check data quality. And what Tableau helps us do is visualize outliers and identify data quality issues quickly and easily. So I'm going to go over 3 specific examples of how we use Tableau for data management. In this first example, you're looking at a question that we asked on our 4th questionnaire. So this is 2012, 17 years after our initial baseline questionnaire. And we asked our women to bubble in their weight in pounds. We created a simple distribution in Tableau to look at the values, and we found that there was a strong preference for 0 and 5, all those different peaks that you see. So what this meant for us as analysts was if we were going to use this variable to generate another variable, like let's say BMI, we had to take that into consideration. Or also, if you're doing an analysis, you had to adjust your statistical models accordingly. In this next example, we look at hospitalization data. And we created a simple distribution of year of hospitalization on the study on the x-axis and total number of records of hospitalizations on the y. And we noticed this. So looking at this, you'd think your population of women are getting sicker in the last 5 years of the study. Either that or we're missing a lot of data in the first 15 years of our study. So the first thing that we did was we parsed out our data. We pulled in a dimension of hospitalization type. And what we found was it wasn't that our women were getting sicker, it was that we were getting emergency department as well as ambulatory surgery data from the state, something that we originally did not get. So we used to just get primary discharge data, and now our data, our hospitalization data, is supplemented. In this last example of how we use Tableau for data management, we're looking at metadata. So as data managers, we can see how many different data sources we get on a specific data domain and through what years. Knowing when we have more than one source of data allows us to compare and better determine what data we can trust and present to our users. So what you're looking at here is just a simple distribution showing year on our study, and y-axis is just going to show the different sources of information that we have. Okay, so we're going to go back to Emma's favorite visual, the rainbow graph. This is our pre-made cancer workbook, which is heavily utilized for grant proposals. Let's say I'm a principal investigator and I'm interested in writing a grant on how many breast cancer subtypes occurred in 2016. All I would have to do is go to this visual right here, go to the year, which corresponds to the different bars, 2016, go to the color that corresponds to breast cancer, hover over, see the tooltip, and see that there are 400 people that are in my eligibility criteria. I don't even need to click anything and do any analyses, and I'm able to get this data and explore it without having to have an analyst with me. Okay, this is my favorite. One thing that we started using in Tableau is forecasting. Using any program such as Excel, you can easily show the distribution of how many cancer outcomes you've accumulated in your population over time. However, what I'm showing on the left-hand side, 5 different sheets in Excel with multiple calculations, it would take me 75 of those to generate what I'm seeing right here. In Tableau, the option of forecasting, all I have to do is click on it, specify how many years out I would like to project my population, and voila, it gets dynamically calculated. So here we're looking at melanoma, but I can also click on the all and show every single type of cancer that I'm expected to see a year from now, 5 years, or 10 years from now. So I'm going to hand this back to Emma to go over one more internal use case.
Thank you. So our final internal use case is how we use Tableau during participant outreach to target our interactions with our participants. Our 6th questionnaire, which I'll refer to as Q6, was originally mailed out in 2017. And it contained some of our usual types of questions, so things like family history of cancer, female health history, but we also touched on some topics that we had never asked our participants before, and this included medicinal cannabis and sexual orientation and gender identity. A really big challenge for cohort studies like ours is how to get participants to respond to the surveys. We've noticed declining response rates to our surveys, and Q6 was no exception. But one of the issues is that the status quo for cohort studies is to mail that questionnaire to every single participant that you can, even if you haven't heard from them in years. So we were thinking, okay, well maybe we want to send out more copies of our surveys to try to get more responses from our participants, especially since we touched on these topics that we never asked them before. But we realized it would be very costly to resend that questionnaire to all of the non-responding participants, especially if it wouldn't necessarily guarantee that we would get that many responses back. And so this led us to the question, how can we identify and target the participants who will be the most likely to respond if we send them another copy of our 6th questionnaire? So we turned to Tableau, we brainstormed, and our next question became, what are the characteristics of a responder? So if you look just at the top box, what you're seeing there is all participants who responded to the 6th questionnaire. The color corresponds to if they responded yes or no to Q5, so that's the questionnaire before that. And what you can see is that the overwhelming majority of our Q6 responders also responded to Q5. Only that little yellow sliver right there are our Q6 responders who had not responded to the questionnaire before that. So that was interesting, and we said, okay, well next let's look at the people who didn't respond. So the bottom box are our Q6 non-responders, and the columns correspond to yes or no, did they respond to all of our previous questionnaires, so Q2 through Q5. What we saw is that the bulk of our participants, that bottom line down there, had responded really well to all of the other questionnaires. So they responded to Q2, Q3, Q4, Q5, and just not Q6. Whereas the people at the top that you're seeing had fallen off somewhere along the way. So some of them we hadn't heard from since Q2, so that was in 1998. And some of them we hadn't heard from since Q3, which was in the year 2000. So after taking a look at all of this, what we thought was, well, let's not focus on these participants who we haven't heard from in years. Let's focus on these people who have been responding so well to all the other questionnaires, and we just didn't hear a response back from them on this most recent one. Tableau allows us to spot patterns like this in our data, like that response was highest among Q5 responders, and I didn't put it in for the sake of time, but also that response drops off around age 80, which might make sense. And we took these insights to target a second mailing of our 6th questionnaire. By making a data-driven decision, our second mail-out cost us $22,000 less than if we had decided to resend that questionnaire to every possible person we could. And it allowed us to acquire an additional 5,550 responses, which means that even more scientific insights can be drawn from the data. I'll hand it back over to Nadia one last time to give a summary and talk about some of our future directions.
Okay, to summarize, we talked about how we've collected millions of data points over the last 24 years, how we've migrated our static, locally stored data sets into a data warehouse where we've applied validation rules and coding algorithms. Also, we've talked about how we have forecasted and documented our populations of interest, and how we've used Tableau to engage our participant community. Additionally, we've talked about how we've worked with collaborators and researchers to explore their data or their data of interest, as well as document their population for analyses. And also, our researchers are now utilizing Tableau more to create more effective visuals that go into their publications. We've cut our project turnaround time from months to weeks for most of our projects. And we've launched 26 projects thus far using our new data structure and utilizing Tableau, and have worked with 104 collaborators and researchers and developed 60 workbooks that are heavily utilized. Each project includes Tableau as a standard part. 80% of our users have never used CTS data before, and Tableau has helped them understand our data better. One of our biggest accomplishments within the last year has been our ability to share our study data on our study website with our study participants. So our participants have always voiced how much they wanted to see how we're using their data, and we now have a tool for doing so. So these interactive graphs and other visuals have allowed our participants to better understand how we're using their data. Similar to how we use Tableau to make our researchers understand our data and make data more accessible, we're doing the same using Tableau for our participants. Okay, so I'm just going to highlight a couple of future directions here. With the success of utilizing Tableau to help our participants better understand how we're using their data, we hope to create more public-facing visuals that go on our website to not only further engage our participants, but also improve participant retention. So in our study, we collect data from many different data domains, such as biospecimen data, residential information, environmental information as well. And some of these areas have been underutilized. With the help of using Tableau, we hope that our researchers are beginning to see the connection between the data and explore potential risk factors that we didn't think about before. And finally, for a lot of our tables and reports that are heavily utilized, we hope to start using Tableau more to create effective visuals, and we hope that our researchers will also do the same, and instead of having to create that paragraph that Emma showed and do some program hopping to create that population subset and document it, we hope that our researchers are going to start using Tableau more to show their data trends and convey concepts in clear ways. As you can see, all of our future directions are going to start with Tableau, not just to connect our data, but also to begin to correlate our data. So we needed someone to plant the seed of using Tableau to get more out of our data, and we hope that this presentation does the same for a few of you guys today. couple acknowledgements. We'd like to acknowledge our co-PIs, Dr. Jim Lacey and Dr. Elena Martinez, as well as our team at City of Hope and our data team at UC San Diego. Okay. If everyone could please fill out a survey if you liked our presentation and hope to see us again next year. 10s across the board, please. And once again, thank you for spending your afternoon with us. If you guys have any questions, I know we went over a lot of content, a lot of different ways we're using Tableau. So please take down our contact. And if you're interested in scientific collaboration, we are also available for that. Here.